Hello there guys and welcome back to another epic and integral maths video. In this video we're going to do this integral right here, the integral of e to the x multiplied by sine x. Okay, what method of integration should we use? Well, the most obvious one would be integration by parts. It's not immediately obvious what a u substitution would be here, and even if we could do a substitution, how would that simplify the integral? I don't know. So integration by parts is the most obvious way to do this. But it's going to be a hard question, or at least an interesting one. So let's go ahead. First of all, I'm going to rewrite the integral, but I'm going to just label it. I'm just going to call it I. So I'm going to say that the value of this integral is I. And you'll see why I'm going to do that later. It's always good practice to do that anyway, just so that you don't have to rewrite the entire integral every time you want to refer to it. So I equals the integral. Okay, cool. Now let's use our integration by parts stuff. So what should be u and what should be dv dx? Okay, well, let's have a think. Well, according to the order of priority for integration by parts, late, logarithms, algebraic functions, trigonometric functions, exponential functions, higher up that list, the more you want it to be u. Well, we have an exponential and a trigonometric. Trigonometric is higher, so maybe we should let that be u. So u is sine x, and dv dx is e to the x. Okay, let's see what happens when we plug this into the formula. First of all, we should find what du dx is and what v is. So du dx is just the derivative of sine x, which is cos x. Okay, and v is the integral of e to the x, which is e to the x. Cool. And then we'll plug into the formula. So I'm going to call it I again. I is the integral of e to the x sine x, which is also, according to integration by parts formula, u times v, so e to the x times sine x, minus the integral of du dx times v with respect to x, so e to the x cos x. Now at this point, guys, you might be thinking, that's pretty useless, because this integral is not the exact same as the original, but it looks very similar. So what should we do? Well, this is what we're going to do. We're going to take just this part of the integral, and we're going to do integration by parts again. I'm going to do it up here, I'm going to do it in yellow, so it's just this, and I'm not including the minus. I'm not including the minus, just this. So the integral of e to the x times cos x with respect to x, we can also use integration by parts to do. Again, we should let u equal cos x, which means that du dx this time would be minus sine x. And we should let dv dx be e to the x, which means that v would again be e to the x. Cool. And then we're going to plug into the formula. So this integral is equal to u times v, so e to the x times cos x, minus the integral of minus sine x times e to the x. Minus sine x times e to the x obviously has a minus in it, and I'm going to take the minus out. I'm going to take the minus one out, and I'm going to make this become a plus, and I'm going to write e to the x sine x here. Okay, cool. Now, you might be saying, oh, we've really messed it up now because we're just back to where we started. This is the integral that we're trying to do. Useless, but actually it's not. So if we write it all in one go, okay, so I, which is the integral of e to the x sine x, is e to the x sine x minus this integral, which we've just worked out to be this. So minus, in brackets, e to the x cos x plus e to the x sine x. But guys, what is e to the x sine x? Well, it's just I, it's just the integral. So plus I here, close bracket. Okay, and now we can just rearrange to get I on its own. So first of all, before we do that, let's just get rid of these brackets here. So minus e to the x cos x minus I. Let's add I to both sides of the equation to get that 2i is equal to just e to the x sine x minus e to the x cos x. And then let's just divide both sides by 2. And of course, we're going to need to add c as well. So if I divide both sides by 2, I'm also going to factor out the e to the x, and I'm going to add the c. So I'm going to do 3 steps in one go here, guys. I'm going to write this as 1 over 2 e to the x bracket sine x minus cos x close bracket plus c. Okay, so I've just done 3 things there. I've halved it, halved both sides. I have factored an e to the x out, and I've added c. Okay, but I did it all in one go, but hopefully that makes sense. So the value of the integral of e to the x sine x is 1/2 e to the x open bracket sine x minus cos x close bracket plus c. And that's all there is to it. So it's a rather unconventional way to do it. This does happen actually fairly frequently with integration by parts, where you need to kind of get the same integral back, so it has this like cyclical nature. This does happen somewhat frequently. It's definitely good to be aware of it. And if it looks like you're about to mess up your integration by parts, it's not always the case. Anyway, guys, hope that was useful. Thank you so much for watching as always, and I'll see you in the next video. Cheers.